Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have x to the power of 8 minus 121 equals 0. So what we're first going to do is we're going to add 121 on both sides to isolate x. We want to isolate x, so we're going to get rid of the negative 121 on this side. So these two cancel out because 121 minus 121 is 0, so we're left with x to the power of 8 equals 0 plus 121 is simply 121. Now what we're going to do is recall a property of exponents. If we have a to the power of b to the power of c, this is equal to a to the power of b times c. So what we're going to do is we're going to change our x to the power of 8 here so that it is in this form, a to the power of b to the power of c. So we're actually going to change this to x to the power of 4 to the power of 2. Because 4 times 2 is 8, and that's x to the power of 8. And this is equal to 121. Now what we're going to do is we're going to take the square root of both sides. So now the square root of this, well, these two just simply cancel because these two are opposites. So on this side, our left side, we have x to the power of 4. And on our right side, we have positive and negative 11. Remember, it's positive and negative, not just positive. So now we have x to the power of 4 equals positive and negative 11. Now we're going to take the fourth root on both sides. So by doing that, these two would cancel out. So we are left with x equals the fourth root of positive negative 11. So this is our answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 10 to the power of 3 minus x equals 1. So whenever we're solving exponential equations similar to this one, we always want to make sure that our bases here, in this case 10 and 1, we want to make them the same. Because let's just say I have a to the power of x, and this is equal to a to the power of y. Well, we know that these two terms are equal to each other or the same, and we can see that both of them have a base of a. Well, in this case, doesn't that mean that their exponents are the same as well? Because if they're different, then that means this would be wrong. They can't be different because their base is already the same, meaning their exponents have to be the same as well. So in this case, if we were to change the bases so that they're the same, then we would know that the exponents are the same as well, so we could just set the exponents equal to each other and solve for x. So we want to make the bases of 10 and 1 equal each other. Well, that means that we have to change one of the bases. And we can't really change 10 to be equal to 1, so why don't we change 1? Well, 10 to the power of what equals 1? 0, right? Because anything to the power of 0 actually equals 1. So we should change 1 to 10 to the power of 0. And this still equals 10 to the power of 3 minus x. Now notice how these two bases are the same, just like this one. And think of 3 minus x as x and the 0 as y. Because these two bases are the same, then that means that these two exponents are the same as well. So we can just ignore the bases for now and just set 3 minus x equal to 0. And now, as you can see, we've created a simple equation using our method. So now, to get the value of x, we're going to have to make it go to the right side. So we're going to add x on both sides. And these two cancel out. So we're left with 3 equals 0 plus x is x. So now we have our value for x. Now, why don't we go ahead and plug it in to our equation? So this gives us 10 to the power of 3 minus 3 equals x. So 3 equals 1. 10 to the power of 3 minus 3 is 0 equals 1. And remember, anything to the power of 0 equals 1. So 10 to the power of 0 equals 1. So we have 1 equals 1. And this is right, meaning our answer of x equals 3 is right.